Hey, Shelby. Hi, Edgeman. Hey, Liam. Hey, Ed. Hey, Paige.
Hi.
Welcome, Andrea. Just wait a little bit longer, see if we get a few more students in. Hey, Eric. You guys having a good week?
Most.
So? Yeah. Feel like things are ramping up, so. Hey, Mike. Hey, Brandon. I know one of our group is getting tested, COVID tested today, so we're going to be one short. But I think I can start now. I think we've got a decent cohort. Today we're going to be doing some Excel work, you guys. We're going to evaluate some of the findings that you had from our day in the woods out at Ruger. And there's going to be some Excel work. And so for this week, I want you guys to be a little more interactive with me. What I'm probably going to have you do is run the analysis on the dry site, but we'll go through the analysis on the wet site. And my plan is to get you set up with your graphs so that once you plug in the values for the xeric site, the dry site, it will just fill in your graph. So we'll get the kind of the graph skeleton ready to go. And so once your data start kind of building into the spreadsheet, it'll auto-populate the graph. I also want to get you through the statistical analysis that we'll do on the abiotic factors. So you can see how that works, and I can show you how to make a different type of graph. But that is the plan. And I don't want to leave you hanging. I'm gonna post a video of the process for both the dry and the wet site. So that'll be posted a little bit later on. I want to give you that opportunity to work through it on your own. There's an assignment that's associated with this, and I'll talk a little bit about that shortly. It's not going to be due this upcoming week. This upcoming week, we're going to be out in the field, back out at Ruger, sampling worms. Very exciting. Halloween, right? Times with Halloween. So we'll meet probably at the gate, and I'll send you more details on that for the week upcoming. But we won't have time to do any presentations together, and that's one of the reasons why we want to hold off and give you a little bit extra time. So this assignment that'll be associated with the forest project will be due not this week, but the following, and it'll be presented as a group together. So we'll share screen, and you guys can, you know, unmute yourselves and make sure that you're speaking when your section pops up on this PowerPoint that you're going to be making. Okay? So let me begin with a share screen. And if you guys have any questions, feel free to reach out, unmute yourself, talk to me. So I want to start by bringing us into our Moodle site, to the forest area. Can everybody see that?
Yep.
Okay, yeah. Thank you. All right, so I am in the Ruger Woods section. And, you know, as I've stepped out here, I've got my overview page. I've got the lab manual module, which hopefully you guys reread a little bit earlier today. About halfway through, you'll see it switch over to the data analysis, which is what we'll do today. There's going to be the Dropbox for the assignment that you're doing as a group. And I just need one person in the group to be like your team captain, okay? So here's what I'm gonna have you do right now. If your name gets called associated with a given group, jot the names down, and I will email this as well. This will be your grouping. So I have group 1 as Claire, Ed, and Naomi. So I'll share that out to you guys, and your email will be in there as well. So group 1 is Claire, Ed, and Naomi. Group 2 is Keely, Liam, and Andrea. So you guys can share contact information. Keely, Liam, and Andrea, group 2. Group 3 will be Eric, Edgeman, and Brendan. Okay, Eric, Edgeman, and Brendan are group 3. And group 4 will be Shelby, Paige, and Mike. Again, group 4, Shelby, Paige, and Mike. And then our Huangs will be group 5, working together, okay? So I will send that information out after our meeting so you guys can connect with each other and work remotely using probably a Google slideshow to process your assignment, okay? But just one person in that group should call yourselves the captain, and that person's gonna be in charge of dropping the assignment into the Dropbox so that we'll be ready to go with presentations in 2 weeks, okay? Any questions on that?
Nope.
Okay, perfect. So we'll click on our overview page. And again, just reminding you guys that the overview page has all the good stuff. It's going to have all the content to remind you of what we covered, to give you helpful hints. A Spark video here, which is displayed right here. And if you kind of forgot what our goals were, and you know what the sites were like, and what the evaluation metrics that we did were, it's all going to be right here, okay? So that information is all in that overview page. Um, Data analysis. So this is where we are today. So our data analysis will be important in your understanding for, writing up the results that are associated with this assignment and kind of interpreting those results. So the three major things that we're going to be evaluating today are density, dominance, and frequency. Okay, so we went and we looked at two different sites, a wet site, Mesic, a dry site, Xeric, and we looked at abiotic and biotic factors. We took measurements, we took soil cores. Taylor, our TA, went and evaluated, did some work in the ovens to get dry weights and figure out the percent moisture on that soil. She took her pH meter and got a pH on that soil. And then you guys looked at light, right, with the densiometer, that disco ball, to see how much light was coming through the canopy, how closed that canopy was. So those are the abiotic factors that you evaluated. And so the three things that we're going to be working to calculate today in our Excel sheet are dealing with the community, so the structure of that forest community. Density is the number of individual trees of a given species. So if you guys remember, the Mesic site had a lot of white cedar. So how many white cedar did we have in that given area that we surveyed? So what was the size of our plots? And you divide the number of cedars that you had divided by the area that you surveyed. The dominance is going to cover the size of the tree. So I think I've mentioned this before, like think of the sequoias, right? Giant trees, and even the white pines, they were really big, right? If you're remembering, if you're recalling it. And so although there may not be many of them in our plot, there were actually a couple of them that were like humongous, right? So you can imagine that their dominance plays a role in forest structure. So dominance is a calculation that's going to get at size of that organism, and it will do it using basal area, drawing from that DBH tape measurement that you guys took. Now, importance is something that we calculate at the end, which is kind of like almost a gut feel value. So we basically will summarize our frequency, our dominance, and our density values into one. We condense it down into one. And so we have a sense of how important that tree species was to that site. But I apologize, I'm remiss. I did not put frequency in here. So say we had 5 plots. There were 5 groups that made those 10-meter square plots. How often do we see that cedar showing up in those 5 plots? So is it only in one of those plots? Then the frequency is 1 out of 5. If it's in all of the plots, then our frequency is 5 out of 5. If it's only in 3, it's 3 out of 5, right? So it gives us a sense of the distribution of those trees on the landscape. Are they clustered together? Are they more common and spread out? So those are the 3 things that we'll be calculating today. Density, which takes into account numbers in a given area. So think of how many stems are in your plot. Dominance, which takes into account the area of that tree, the size of that tree in your plots. And then frequency, which takes into account how often we see it across all the plots. Is it common? Is it rare? And we'll get a sense out of those 5 plots, how often are we seeing it, okay? So I want to orient you here to the raw data. So you guys should download this onto your computer, okay? And when we open it up together, we'll be working through some of the calculations, but you'll be filling in the tab for the dry stuff, the Xeric site, okay? And I'll show you that in a moment when we get there. As you scroll down a little farther, you're going to see that there are references to these 2 field guides. They're called Silvix 1 and Silvix 2. And these become important in your assignment, okay? So I wanted to make sure that I gave you a little bit of attention with these Silvix resources. If you click on Silvix 2, it's going to bring you to this. And this is basically a field guide to all the hardwood trees in the United States. And, we can kind of scroll down. We can see one that might be one that we might have seen. For example, maybe the ash tree. okay, the white ash tree. If we click on it, what it's going to bring up is the range of the ash, which you can see is kind of eastern distribution from north to south. The climate needs, the soil type that it needs, so a pH tolerance of 5 to 7.5, that could be super important, right? Why do we see it in one site versus another? It could have something to do with the pH if it's off the scale of what that soil was, right? So again, soil type, soil texture, all of these things can show up in the Silvix. You know, what do we see it associated with? Life history characteristics. All of this could be referenced in your explanation as to why you see that ash tree in one site versus another site, okay? And then the same is true if we switch over to the conifers in Silvix Volume 1, and we went over to the white cedar, and that's Atlantic white cedar. We need Eastern cedar, so that's Thua ox. But again, if you looked at this, you know, you'd be looking around northern white cedar, Thua ox. Well, where do we see it? It's a little bit more northern distribution, so we see it where we are. And here's the soil needs that it has, and the associated forest cover and so on. So again, I think it's important for you in your presentation, as you're trying to explain why one community might look different from another, why we might see one tree species in one community over another, for you to draw from these two Silvix resources, okay? So I wanted to make sure you guys saw where those were. And as always, with all of my assignments and in my Moodle sites, I like to give you guys a head start on potentially useful articles that could help explain things, right? So if you're thinking that an abiotic factor like moisture becomes important in explaining the trends that we're seeing, then this could be a useful article. You know, pH as well. Biotic factors, I pulled a couple on herbivory and deer. Even land use history, the fact that it may have been a farm, a working farm in the past where they've kind of removed trees and tilled the soil and dug some things up. These articles could be useful as you're explaining things in your assignment, okay? So that's kind of set the stage. The assignment itself is listed right here. You can hyperlink to it and it's going to bring this up, okay? So just kind of before we jump into stuff, I want you to see what we're looking for. You guys will be presenting this orally in a PowerPoint form. So you can open up a Google Slide show, and that would probably be the best way for you to build it as a group, right? The slides need to be clear, your delivery needs to be practiced, it needs to be well organized, and me personally, I like to have a picture on every slide, make it, you know, eye-catching. But what is the content that's necessary for it? It's right here, okay? So you should have an introduction, just similar to kind of what we've expected in the lab report, maybe a slide on abiotic factors that influence forest community structure. So those are the things that you guys evaluated: the soil type, the soil moisture, soil pH, the biotic factors will be another slide, you know, so you'll speak of maybe forest disease or woodpecker damage, deer preference, those sorts of things. You should certainly have, you know, starting this off with a title slide so we know who you are, and have the title be informative, but you lead us in just like you would in a lab report with the introduction. You should also have a hypothesis, right? You know, which of those sites did you predict would, you know, be the most diverse or, you know, have the most interesting structure? And we'll cover that. So species richness, the number of species that you predicted in one site versus the other. Maybe right off the bat, you had a sense that, you know, maybe the one that's got more water has more species. But that's just based on your own experience being out in the woods, right? So you would state your hypothesis, and it's totally fine if that hypothesis gets like trashed later, right? Now you should have a slide on methods. You don't have to go super detailed because everybody's method slide will be exactly the same, right? But you can speak to and maybe include some pictures. If anybody took pictures in the field of us reeling out the meter tape, measuring around the tree. You can gather some of that information. And I actually think I took some pictures that I can share out with the group as well. But don't forget also, you should probably state we're calculating density, we're calculating dominance, we're calculating frequency and importance, and we're doing a t-test to see if there's a difference in our abiotic factors like our soil moisture, soil pH, and light levels in those two sites. Remember, comparing two sites, some variable measured at both of those sites, we do a t-test, right? The results. So after today's data analysis, you guys will have graphs. You'll have a lot of graphs. One for density, one for dominance, one for importance, one for frequency, and then also for those abiotic factors. So you'll include those in your explanations, okay? I'm going to assign, and I'll send it out in an email, I'm going to assign probably one variable to each of those groups. So for example, group 1 might get assigned light level. Group 2 might get assigned soil pH. Group 3 might get assigned soil series, and so on and so forth. And that would be sort of the vein that you dig into a little bit deeper, right? So you're going to, if you're assigned light, you're going to take the t-test on light and explain why it was different or wasn't different in explaining the trends that we see, okay? And your discussion, again, this is where you draw from the literature. So why did we find those trends in soil or light, as well as the community composition? Draw from the Silvics, using, Silvics to help explain, as well as some of those articles. You can throw in your sources of error, how you might improve upon it, and so on. And be prepared for questions. I may have a question or two after, the audience might have some questions too. But we want to learn, what you were able to research. We're all doing the data analysis together, but you guys are the ones that have the opportunity to explain why or maybe why not that variable was useful and informative in explaining the differences in the trends in those tree communities, okay? So again, not due next week. That will be presented 2 weeks from now, because we're in the field collecting worms hopefully next week if our COVID levels are low. Okay. All right. So just reminding you, our lab manual, that section that I handed out to you guys, has the calculations here for the community analysis that we're going to be working on. So you can reference it. Also, it ends with the rubric. Okay, so if you were wondering where it is, that is where it is. Okay, are we ready? Let's do this. All right, it's going to take us a little bit to get through, and I want us to orient and make sure we're feeling comfortable with it. So if on that Moodle site you guys jump down to the raw data and opened it, downloaded it onto the computer, like I'm hoping that you will be seeing, I just hide us. You'll be seeing this, okay? And there's going to be some tabs. There's a MESIC tab, a Xeric tab, a comparison tab, which is the tab we're going to use to make all of our graphs, an abiotics tab, where your data on the soil moisture and so on are located, and a biotics tab, where your observations of woodpeckers and beech bark diseases and so on were located. And that's just kind of anecdotal. This is just something that you noted when you were at the site. We can't do a statistical test on it, but we could use it to help explain some of the findings later on. The code key over here is just showing you what those abbreviations mean, okay? Everybody feeling good? Oriented?
Yep.
Okay. All right, so let's start up here. The number of plots, and this is just so you understand, I think we only had 2 groups, but we combined our data with Dr. Lesser's lab, so we actually have 5 groups that we're going to be evaluating. Your plot size, you made a 10 by 10 meter square plot, so that's 100 meters squared is your area surveyed by each of you, okay? Foresters like to convert metric stuff to this unit called hectares. So the first thing that we're going to do is we're going to make a calculation, basically just a conversion. How do we convert meters squared into hectares? So for that, I'm going to put my cursor on the cell of interest. I'm going to type in equals, and we basically need to divide our area that's metric by 10,000. I have one extra, I think, right? Yep. Whoops, I'm not working in an Excel sheet. Sorry, guys. I was working in the online version. And that's why it wouldn't let me change. 10, 1, 2, 3. There we go. Okay, so 100 meters squared is equivalent to 0.01 hectares. Everybody with me? Okay.
Yep.
All right, so our total plot area, there were 5 groups, right? So if everybody's plot area was 0.01 hectares, we need to multiply that by 5, or I can just click on this 5 plots times my plot area, and we have 0.05 hectares were surveyed by everybody across these 2 lab groups, okay? All right, so again, for orientation, we're in the MESIC site. These were all the species that Taylor color-coded for us. These are the groups. This first column is the column of groups, right? We should have 5 groups. And then you guys did your DBH, the diameter tape, you measured that, and Taylor entered that down the row here, okay? So we're gonna begin our major calculations in this region right here. And you'll notice as we do that, that this like magic table over here is our summary table, and it's gonna autofill, okay? When it gets down to our time where we have to do our frequency calculations, we're gonna move down to this area. But for now, we'll be building in here, and you'll be seeing stuff growing over here on the right-hand side, okay? So the first thing that we're gonna need to do is we're gonna need to figure out how many individuals of pine straw or white pine that we had, right? So this is the N value. And it's gonna help us to get to the density calculation, okay? So to do this, and feel free to jot this down, but you're also going to have access to it in the video, we're going to use a formula we haven't used before, and that is count if, okay? Sometimes we use equals sum, sometimes equals average. Those should be familiar to you, but in this case, we're going to use count if, okay? So basically we're saying count this if the value in the cell is this one. Okay, so let's see how we build this formula. So equals count if, open parentheses, and now it's going to give us a little cheat here, right? So count if, what's the range? So it wants to know where the data are, and then the criteria would be, well, what are we going to count it if it matches up to? Okay, so I'm going to scroll over here. The range that we need will be the species. Okay, so we need to do this with the species. And I don't know if you remember, you guys, but if you want something to always stay the same, we put $ around it. Okay, so you could go up here to the formula and put a $ around the front and the back of the B and around the front and the back of the B. But if you just hit F4, it does it for you. Okay, so basically we want our range to always stay the same. The data will always be the same that we're counting, but you put a comma and now you need the criteria. What are we going to count if it's like, if it matches it? The criteria will be pine straw, okay? So basically we're counting in the column of species. It'll always be that column of species. And the thing that we're going to count if is if it equals pine straw. I'm not putting $ around that because we want to drag across, right? We want Excel to help us. So that pine straw is associated with G8. And if I put $ around it, it would always stay G8, but I want it to be H8, I8, and so on. So I'm going to just put a parenthesis on that and end it. And now I can drag across. Ta-da! Okay, so what this is telling us is there were 8 white pines in our survey, all 5 groups surveyed. And if I scroll down looking at light blue, which is the white pine, and counted all of them, I would probably find that there were 8 of them. Okay.
What button did you press to put all the $ on them?
F4 is the magic button. Yeah. Yeah, and so when you're working on your own, you guys will have this video. You can play it again and pause it. I'm going to be posting it after, and there's also a completed one that will be posted for you to access that'll work you through the sites, okay? So,
Okay.
but the dollar signs will come with an F4 button after you've typed in your range. So what I did is, you know, we count if, grab the range, the column of interest, put dollar signs around it because we always will go to it. And then your criteria will be the value of the species of the cell that you're in, okay? So if I click over here to the pine res, notice it went to H8. So now it's only going to count the ones that match pine res. And there's only one in all of this. And the rock hat, there's only 4. Thu ox, are you guys surprised? Probably not, right? 30 Thu ox, we had a lot of them, right? Okay, so that's the N calculation. How many of those individual species specific to each did we have? And the total should be simple, right? That's a simple formula, equals sum, and you can highlight what you want to sum and hit enter. Now I can queue this up. I can drag that corner all the way down. Those zeros will fill up automatically as we build the rest of this table, okay? All right, everybody with me?
Yeah.
Okay, that was count if. So density, remember, is N, which we just calculated, divided by area. So equals your N, click on your N for that species, divide it, the total area that we all surveyed was this 0.05. We want to keep it at that always, right? So we're going to hit that F4, that magic button, and now we can hit enter. Okay, and that calculation, I'm just going to drag it all the way across. All right, so you'll notice that denominator never changes, but my numerator will change all the way across. All right, what we tend to graph is stuff in relative proportion. So relative density will be what we graph ultimately, okay? And relative density is just, it's a simple calculation. It's just simply equals your density, so click on your density above, divided by, click on the total density of all the trees, okay, at the end of that column. And again, that is never going to change. The total will never change, so I'm going to hit the F4 on that. And I want to make it a percent, so I'm going to multiply it by 100. So again, it's basically the ratio of your species density to the total density times 100. And I'm going to just drag that corner across. And
Can you show the density calculation again? Mine keeps coming out as 0 for the.
oh, sure, yeah. And don't fret, you guys, if you get bogged down. This video will be there. You can just pause your way through as you go. But yes, I can certainly show you that. So the density calculation is just N. So equals, click on your N value. In this case, it was clicking on the 8. Equals, click on the 8 divided by the area, right? N divided by area. And the area will always stay as 0.05. So you put the dollar signs around it. Okay. Now, what's important to note is when we do these relative things, they all should add up to 100. The relative ones are based on a percentage. So if we overshoot or undershoot, we've done something wrong. So that's our way to check. Okay. All right, now we're on to dominance. So density was just the number of stems in our area, right? How many of those individual stems did we have in that given area? Now we're going on to dominance, where we're going to think about how big that particular tree species was in the plots. How much space did it take up? We have to do that by using our diameter measurements that you guys evaluated. Okay, so I'm going to go over here because before we do that dominance calculation, we have to actually convert this basal area. Think of the size of that tree. So the basal area calculation, remember, you guys measured diameter, okay? And the diameter of a tree is pi r squared, right? It's a circle, right? Pi r squared. We're going to be, that's the area of that circle, right? So we're going to actually have to do a calculation to arrive at this basal area. And we're going to use this conversion coefficient here, the basal area conversion coefficient. So it's simply going to be equals, click on that conversion, which is going to take our circumference, right, and help us to convert it to the radius and to the, using our calculations for the area of that circle. So we're taking that, and it will always be that coefficient remains. So we're going to hit F4, okay? We're going to multiply it by your diameter raised to the 2. So we're squaring the diameter, and we're multiplying it by this basal area coefficient. Okay, that coefficient always stays the same, so it gets the square, and we're just squaring our basal area calculation. And I double clicked the corner. You can also grab it and drag it down like we usually do. Okay. All right. So again, pi r squared, area of a circle. We took the diameter. We need to convert that to a value so we can get this basal area. It's simply your basal area coefficient times your diameter squared. Okay. And now I'm on to our dominance calculation. So dominance is going to be the sum of the areas that you just calculated for that tree species. So if I was doing this old school, I could sum up the basal area for the light blues. So equals sum, see there's the 0.141. If I scroll down, I would also want to sum this group into that. And if I scroll down, there's probably some more pine straws. I'd want to sum all of those, right? Because Excel is smart, we can use it to help us. So we can use, instead of the equals sum and grabbing all of those light blue ones for the pine straw to figure out how much space the pine straw white pine took up, we can do equals sum if, okay? So for the sum if, we're going to need to look at our criteria here, right? So they want the range and the criteria that we're going to evaluate, and then they want to know what we're going to sum. So where's the range of the stuff we're going to sum? So sum if, open parentheses, and we're going to highlight your species column. So we're going to sum if your species, and they want to know where that is, and we're going to hit F4 because that'll always be the same. Comma, now they want the criteria. Well, we're in the cell for the pine straw, so let's click on the pine straw. Okay. And now we want to know, so I'm going to put a comma, what the heck are we going to sum? We're going to sum the column of the areas. So we tell it where that column is and hit F4 again, because that's going to always stay, and end parentheses. Okay, so we took the range. The first range of the sum if was our column of species. We had to put a comma and tell it what criteria, so what species we want to look for, and then we needed to get the range of the things we need to sum, which was the area, basal area. So I'm going to grab that corner and drag it across. Now remember, relative dominance, just like relative density, is the dominance of the species of interest divided by your total dominance right over here times 100, okay? Equals, click on your dominance for pine straw, divide by your dominance total of all the trees that you looked at. And we're going to hit an F4 on that because that will never change, and multiply that by 100.
Danielle, I just have a question.
Sure.
When I drag, like when I got the 1.14 and I dragged it all the way across,
Yep.
when I hit the total, it always just gives me a 0. Did Ed just ask the same question?
Ed just asked that same question. So what I would suggest is to go back up here, you guys, and do that equals sum again and drag that corner all the way down. Maybe yours isn't refreshing.
Just put equals sum.
Yeah, see up here, I've got equals sum, and you're summing up your whole row, and hit enter.
Mm,
And now grab that corner and drag it down again. That may fix your problem. You may have just dragged kind of too far across and not stopped like at the end of your tree species. We can do a one-on-one help if you guys are needing it afterwards, but my suggestion to you is to kind of to watch through this and perhaps work as you are. If you run into some trouble, you can go back and review the steps on the video, you know, pausing it along the way. And then if we really are struggling, you guys can shoot me a message, or we can do our Zoom one-on-one, okay?
okay.
All right, so we've got our relative dominance. Again, remember, relative is all relative to 100%. So it was good that we added up to 100. And now we're down to frequency. In frequency, we mentioned we've got to do something a little bit different. So we're going to scoot over here before we go ahead down to our frequency area. Okay, frequency, remember, is of those five different groups. Did every group see it? Did only one group see it? You know, what did we find? And that's going to kind of get at the distribution of that particular group of tree species. So in this case, we're going to use a different formula. It's called count ifs. So not count if, not sum if, but count ifs. So equals count ifs and open parenthesis. Now again, it's prompting us to figure out what we need to count here. So what we need to do is we need to find the range of our groups. Okay, so we're counting if the groups, so grab the groups series, that column, hit an F4 around it. Okay, put your comma. So our first criteria is we need to know, you know, group. We're looking at, is it found in a group? Okay, well, the criteria is which group are we interested in? Well, at this moment we're interested in group 1, so I'm going to click on group 1. Okay, now for this calculation we need to put a $sign in front of the 19, and this is basically going to be securing the row and not the column on that one. Okay, so just $1 sign right before that number. The next thing that we need to do, and it's going to prompt us again, is find another criteria range. And in this case, well, we know what group we're interested in. Is it in the group? Now we need to say, well, where's the species? Because we're going to count it only if it's in a species range. So we'll go and grab this one. We'll hit the F4 again, because that also will stay the same. And, well, what species in this particular cell, what species is of interest? So we click here. In this case, we want our column to stay the same. So we're going to put a $sign in front of the letter, but not in front of the number. And I'm going to close that and hit enter. So this has just told me that there should be one pine straw in group 1. So let's double check that. Let's go and check it out. Here's group 1, and look at that, just one pine straw. And so what I'm going to do is I'm going to go over here and drag that calculation across. So group 2, this tells me group 2 has 0 pine straw, no white pines in 2 and 4. There should be 4 in group 3, and in group 5 there should be 3. So what did we just say? 5 should have 3. Let's go down and look. There we go. 5 has 3. Okay. So you guys set that that was a pretty intense calculation. Okay. We can look at that again because it is pretty intense. So we're going to count if it's grabbing a first range. The first range is our group. It's going to count if, where's the group? Here's the criteria for the group. So this is basically saying group 1. Count if group 1, the next criteria it needs is the range for the species. So we're going to count if group 1 has a species, and the criteria for that species is right here. And that was the pine straw. The fact that we placed a $sign in front of the number right here and a $sign right in front of the letter right here will allow us to take this row and grab the whole corner and drag it all the way down. Okay, and again, it's basically saying we have white pine was found in group 1, just one of them. In group 3, there were 4 of them, and so on. Okay, but frequency is not summing that up. Frequency is finding out, of these 5, is it present or absent? Okay, so it's basically saying, if there's a number in here that's not 0, I'm going to count it. Okay, so the formula here for total is a count if formula, equals count if. Okay, and we basically need to take that whole row, that's what we're evaluating, and we're going to put your comma because the criteria is going to say, in quotes, if it's greater than 0, if we have a value that's greater than 0, I'm going to count it. Okay, so in this unit, in this row, okay, if anything is greater than 0, then I will count it. And we hit enter, and let's double check. 1, 2, 3, right? So in 3 of those groups, we actually had pine straw. And now I can grab that and drag it all the way down. Okay, so you can see here in Thuaux, 5 groups. Each plot that was surveyed had a Thuaux. Okay, this column right here is what is important for us to build the frequency. Okay, so I kind of want it to be in the same visual window. And I need to see my species too. Okay, I'm just going to knock this down in size if I can, just a notch so we can see it. Okay, oops, I need to hide us. Here we go. Okay, so frequency. How often out of the 5 groups do we see that particular tree species? I'm in the pine straw, so it's equals, click on the number of times, the number of groups that had it, divided by 5. Pine res equals, click on the pine res total, divided by 5. Raw cat, divided by 5. Thuaux. This one's going to be, everybody's got it. Whoops, that should not be. Not 235, that's not the cell I'm looking for. All right, getting close, guys. Beautiful. All right, so that is the frequency. Frequency is, of our 5 plots, how often did we see if it was present or absent? So in, pine straw, our calculation is going to be 3 out of 5. 3 out of 5, or 0.6 is the frequency. Now, relative frequency, remember, relative is the proportion of that particular tree species frequency divided by the total of all the trees' frequencies. So equals, click on the frequency, divide, click on the total frequency, which always will stay the same. So we're going to put our $signs around it, times 100. And we can drag that across. And awesome, we've summed up to 100, which is what we're looking for. Now remember, importance, that's kind of like the gut feel, right? You want to know how important a tree is. It takes into account the density, the dominance, and the frequency of that tree. Okay, so that one is a simple calculation of equals sum And now we're just going to hold that control button and click on your relative density, your relative dominance, and your relative frequency. So we're basically looking at summing all of those relative values that you guys just calculated for that particular tree species. And now we want this to be on a scale of 0 to 100, like we did with all this other relative stuff, right? Because it's basically a relative importance. So to do that, I'm going to divide it by 300 because ultimately this is out of 300, right? Because our scale for all those relative ones was 100. Adding those together is 300. So I'm going to divide it by 300. And then to make it a percentage, I'm going to multiply it by the 100, which is our typical thing. And I'll drag that across. Okay? Otherwise, this would have been up in the 300 level. And we want them all to be kind of on the same scale. All right, so again, the importance is the sum of your relative density for that particular tree species, the relative dominance for that species, and the relative frequency summed together. We divided by 300 so that we were on a scale of 100, and we multiplied it by 100 so that we could have it as a full percentage, okay? So that is the sort of community structure analysis that you guys need to do. And you'll notice that summary table right here has filled in for you. And that's going to be important when we do our comparisons. So your job, and I'm not going to cut you loose yet, we still have a little bit of work to do, will be to go to the Xeric tab, come over here, fill in your plot area. Remember, to convert to hectares, we took this value and divided by 10,000. Multiplied that by 5 to get the plot area over here. Just if you were thinking, because I'm looking over here, basal area, remember that conversion was just equals your basal area coefficient times your DBH squared, dragging it down. But again, remembering this is always constant, so you put your dollar signs around it. When you go and you do your individuals, it's you're going to be doing your count if calculation here, right? When you go and do your dominance, you're doing your sum if calculation. When you do your frequency, you're over here doing your count ifs in that extra table right there, okay? And the importance, you're just summing all the way across, okay? So again, you're gonna have a video that you can pause along the way to help you guys to get through this, but I didn't want to do it all for you, kind of you just watching. I wanted you to have a little bit of interaction, okay? Let's go over here to the comparison tab, because ultimately once you've filled out your Xeric, we want to come over to the comparison tab and actually make the useful graphs. We scroll up to the top here, and you can see there's a table for your relative density, one for your relative dominance, one for your relative frequency, and then one for the importance, okay? And over here, we have sort of community and biodiversity calculations. That's just kind of an additional thing that I think is important for us to consider, and we'll talk about shortly, okay? But what I want to do right now is, you know, like, basically this is just a summary table. As you did this, you created this, and this is what needs to paste into that comparison tab. So for example, the mesic relative density, these values right here would go in this column, okay? You just paste them into that column. However, you can't just copy paste them because the mesic site might not have all of those species, right? And then when you go to the Xeric, you know, once you do your Xeric calculation and it fills in this summary table, this relative density column belongs in this Xeric area. But again, Xeric may not be in the same order. These trees might not be in the same order. You can't just direct copy paste, okay? When you go down to the dominance, you're grabbing the dominance here, right? But again, you can't just direct paste it. And that's why we're going to use another formula that I want you to be familiar with. And we can set it up so that you'll be ready to go. As soon as you fill in your xeric, it would auto-fill, okay? And so for this, we're going to use the VLOOKUP function, okay? Equals VLOOKUP, open parentheses. So it wants to know what value are we looking up and where is the table where those data are located, okay? So the VLOOKUP value we want is thuaux. So we click on the thuaux, comma, where the heck are those data? So this is where we actually go to the MESIC tab. So we click on the MESIC tab and we just highlight the summary table, okay? And that summary table will always be the same. So we F4 it to put the dollar signs around it. And you'll notice as we look through here, the lookup value we said was the thuaux. The table array was this summary table. We made it a dollar signs around it. The column index, where is the data for the density? Column 2. So I'm going to put a comma and write a 2 there. So I don't want it to grab the dominance, which is column 3, or the frequency right now, which is column 4. I just want the densities. So that is the 2. That's what the 2 means there. And then as I proceed through, it's telling me, okay, I need something else, range lookup. When I go and I do that, I'm going to look up, I don't want an approximate match, no way. I want an exact match, so I'm going to type in the word false. So VLOOKUP is going to an area, looking up A3, which was your thuaux, going to that MESIC summary table, which I have right here, it's referenced right here, and pulling from that second column to see if thuaux is in it, and reporting back, basically pasting that value into the table. And the false here is just saying paste the legit value, okay? So we'll hit enter and notice it just pasted that 60 there. And if I grab that corner and drag it down, it brought in all those other ones. If we go back and look, right? It brought in everybody else, okay? Now for the xeric, we can do the same. We can set it up for you guys so that when you do it, you can bring, it'll just auto-populate and we can make our graphs based on this. So for the xeric equals VLOOKUP, right? What are we looking up? What value? Thuaux. Where the heck is that thuaux for the xeric? We go to the xeric and we need to find our summary table, which if we just need to scoot over, highlight your summary table. It's always going to be that. So we hit our F4. We're graphing, and this table is for density. So again, the density is, the relative density is the column 2. And we'll type that false in again, okay, because we want it to be that exact value. And then we'll just drag it down. Now notice it's showing up like with all these zeros and stuff. That's because you haven't done your calculations to fill in the xeric yet. It will auto-populate for you, okay? So that is how the VLOOKUP works. And that way you don't need to worry about flipping back and forth or taking a picture of the screen with your phone and then typing the number in by hand. That VLOOKUP will actually do the work for you, okay? Now, if we want to make a pretty graph of our densities to compare those two sites, we can't do it with all these NAs, okay? Now, mind you, the graph isn't going to be super informative. It's not bringing in the xeric at the moment because you guys haven't done the calculation. But if we set the graph skeleton up, then you should be able to just look back and it'll be already calculated for you. So what I'm going to just suggest to you guys, it's important to note, is you need to clear out these pound NAs. That's going to make it very, difficult to graph. So highlight them, you can right click and you can clear the contents. I would wait on the xeric until you auto-populate it, until it auto-populates when you've done your xeric calculation, okay? But let's make a graph together so you can see how to make a graph. So we're going to grab the two sites as well as the species name, and we're going to highlight them. So I've just highlighted them like this. And this is similar to what we did with optimal foraging, okay? We'll go over to insert, and we want to make a bar graph. So all of these, you know, relative density, dominance, and whatnot, we want to make a bar graph of them. So I'm going to click on bar graph. I'm going to click the first one there. And it just made a graph for us, okay? When you have your xeric stuff in there, you're going to see some orangey bars that will pop up, okay? Because xeric is coded in the legend here as being orange. So I'm going to delete my title, and I want to make this informative, right? We talked about this before as a group. We need to insert chart elements. So we'll go over and insert a title. The primary horizontal title would just be, these are our species, right? And we're going to add a vertical primary, which would be relative. Notice I'm typing it in the function window here. Density. And if you want, you could put that in as a %. Okay, and as I mentioned, this graph, it's all nicely aligned and everything. As soon as you guys do this, you know, do this table here, it'll auto-populate that. And because you built your formula already with your VLOOKUP, it will auto-populate this. You'll just need to come in and clean it up, get rid of those NAs, and it will show up with your orange xeric values as well, okay? But what this is showing us in this graph is that the relative density in the wet site, the mesic site, which it's nice that it's blue because it's wet, right? Water. We are totally, the most dense species is the thuox. There were many stems of thuox in everybody's plots, okay? Pine straw is second, right? Runner up, but not as much. Okay, we can go down here to dominance. Again, just giving you guys some, you know, setting you up so you can do that other one on your own. So again, VLOOKUP, what are we looking up? Thuox, comma, where the heck is that thuox? We're in mesic again. But this time, we're not interested in the density column, which was the second column. We're interested in the dominance column, which is the third column, okay? Remember, that table will never change, so I'm gonna hit F4, okay? And column 3 was our column of interest, and false, because we wanna report back the exact value, okay? And we can drag that down. I'm going to go back and clear that out. This has happened to me one more time, that we do have a pine straw, which is in the mesic. So I want to just make sure that that it's showing up, because for some reason it's not there. So equals, what did we do? We did VLOOKUP, thuox, comma, go to the tab of mesic, show us the table, hit F4, because it'll always be that, comma, we're interested in the 1, 2, 3rd column, and false. There we go. I knew pine res was there. Okay, so now we're in the dominances. We've got all these NAs that we don't want, so we can highlight and clear those contents. And again, we can set you up with the xeric, right? Equals VLOOKUP. Thuox is what we're looking for, comma, where the heck is it? Go to the xeric tab. Tell us where that summary table is. Hit your F4, because it'll always be that. We're again still doing dominance, so that's the 3rd column. False, because we want it to report that. What? That does not seem right. Oh, you know why? I'm sorry. I don't have a way back. It's because you guys don't have it filled in yet. Danielle's losing her mind. No wonder it was all zeros because it's not filled in yet. So equals VLOOKUP, we'll just practice it. The value we're looking up is through aux. Where is it? The Xeric summary table. Hit F4 because it stays there. We are in column 3. False. There we go. Yes, so leave it. Leave it at the 0 until you guys have done your analysis. So remember, once you do your analysis, it's going to auto-populate. You can clear out those NAs. You can do this. Whoops. You can go insert your graph, right? Insert that bar graph, the first one. Delete that embedded title. Add those chart elements for your X and Y axis labels. And it should auto-populate, okay? So you would proceed in doing that for all of the rest, so relative frequency and then relative importance. You guys cool with that, or do you want me to kind of walk through that again? Are you feeling confident with that step with the VLOOKUP?
Yeah, kind of.
Yeah.
Okay. All right, yeah, so not to belabor it, and again, because you can pause the video as you're going if you have somehow forgotten the equation, I will skip over that. Just know that we're expecting you're going to have a graph of those relative densities, relative dominances, relative frequencies, and relative importance there, okay? I'm going to scoot this graph over so that we can talk about this community analysis here. So one thing that community ecologists will do when they go to a couple of different locations, imagine we set up a game camera, right? And in one area we got northern and southern flying squirrels, we got chipmunks, and we got mice, and we got a red squirrel. So we had a species richness of 5. In another site, maybe we just got a bobcat and a coyote. We would have a species richness of 2. Maybe we got nothing at another site. So that's a totally depauperate site. So that would be a species richness of 0. So species richness is just a count of the number of species you've got. So in the case of these trees, if we want to know what the species richness of the community that's the Mesic community is, we just do equals count. And we count the number of species. You just highlight what you've got, okay? And it basically it puts a record of how many unique species, and we're not talking numbers of them. We're talking we had how many different colors is pretty much what it is in this case. 8 of them. In the Xeric site equals count, and it's not going to likely do it right now, but we can kind of set it up, right? And I want you to do that yourself because I don't have the data in here, right? But when you do, and you do equals count and you get rid of those NAs, it will count up how many unique species you've got. And my guess, because if you guys remember, when you look at this table versus looking at this table, right, there's way more, right? So the species richness in that Xeric site should be greater than the species richness in your Mesic site. And that will be an important thing, right? Communities that are more biodiverse are really robust, right? If a hurricane comes through, they have a better chance of survival. If you're worried about Lyme disease, the more diverse your community, the less likely you'll probably have Lyme disease. So there's lots of reasons why looking at community diversity is important, okay? So once you've auto-populated your stuff, if you did an equals count, like we did here in the Mesic of the Xeric, you'll get a value for how many species you've got in that community. The one other community diversity analysis that you and Dr. Aldred will be doing likely later in your semester is this Shannon-Weiner Diversity Index. That takes into account not just the richness or number of species that you have, but also like proportionally how many are there. So remember in the Mesic site, in the Mesic site, we had a ton of Thu auks, right? And so a ton of thuocs and maybe not many of anything else. So it's very dominant in the community, and everything else was kind of rare. So proportionally, it's like way overpowered everything else. If some disease comes through and takes out those thuocs, that could be a problematic community, right? In terms of diversity, it doesn't have very much. But if we had like 25% in each of those species, that's a much more evenly represented community, and that's something to note. So I wanted you at least to walk through with me, and then you could do the other one on your own, how to calculate this for this Shannon Weiner diversity index for the MESIC site. And so to do that, I'm going to use a COUNTIF function. You guys have these data, the N values, already. I'm going to just scoot the graph down farther. You have it already right here. If we go to MESIC, this is your N number of individuals, okay? Instead of just like pasting it, right, because we mentioned that can be problematic, we can actually do one of those formulas, right? In this case, we're going to do an equals COUNTIF, okay? Where's the range? Where's the criteria? Okay. So we want to go to the MESIC, and we want to go over to our column of species, because we're looking generally at the whole community. So we highlight all of it. We're going to hit F4 because it'll always be the same. Okay. What are we interested in counting? So we choose the criteria, and the criteria is thuocs. Okay. We can drag that down. That's not right. Equals COUNTIF. There we go. I'm not quite sure what was off there, but we're really just doing sort of like what we did with the VLOOKUP, telling it where to go, and pulling the criteria, which was to count from that column of all the species, just those thuoxes. And I can drag this down. Okay. Now, relative abundance is N that you have for that species divided by your total. So this formula is the N divided by the total. And I can drag that down. Oops. The total is always the same, right? So I forgot to put the F4 around that. Okay. Now we take the natural log equals ln natural log, open parentheses, of the relative abundance, which was this column right here. It's okay to be negative. Well, I don't want you to be negative. I want you to be happy all the time, but negative value. And then your final column is, and again, you're going to learn all this with Dr. Aldred in greater context when you're talking about community analyses, but it's just one more thing that we can build into our presentation. So our final column is equals the relative abundance times the ln of the relative abundance. Well, these values are just right here, right? This is the ln relative abundance. This is the relative abundance column. So equals, click on your relative abundance column, multiply, click on your ln of your relative abundance, and hit enter. So we just basically cross multiplied these two columns. And we can drag that down. All right, now we can get rid of these empties because we just didn't have those species. Now notice my prompt is right here. The Shannon-Weiner is the negative sum, so the absolute value pretty much, of that final column, this final column right here. So equals negative sum of this final column right there. Okay, and it should autofill right up here. So when you guys go down and do your xeric, right, I have a table right here, okay? That I was working on earlier, right? So equals count if, you can see it up here. You reference back to the xeric tab and highlight the column of the species. Hit F4 because that'll always be that. Comma, and then you click on the one that you want to count, which in this case was the thuok. Hit enter and drag it down, and it should do the same for you. Again, relative abundance should be equals that value of n divided by the total, and the total will always stay the same, so you want to put your dollar signs around it in the denominator, drag it down. This one you just take the natural log equals ln of this value, and this one you cross multiply equals this value of relative abundance times this value of the ln of relative abundance. Clear out anything that might be a weird pound num, right? And do an equals negative sum of that final column right here that you highlight, okay? And that would autofill right here, right next to what you've got for your MESIC site. So again, you can, in your discussion, in your assignment, not only can you have your graph of density, dominance, importance, and so on, and kind of show how those trends vary, but you can also have these diversity patterns that you could draw from, right? Again, Shannon-Weiner speaks of how even the proportion of each of those species is in that community compared to one another. It's always good to have, you know, more evenness than to maybe be dominated by one, because a catastrophe like a disease or a flood or a hurricane could come through and disturb that one species that you were counting on. But also sometimes the one species might be one that promotes disease and things like that. So you can get it a lot in kind of explanation by dealing with species richness. Again, number of species of trees that you had in that community, basically how many colors, right? How many different species, because we've color coded them uniquely. And then the Shannon-Weiner, which kind of brings in the species richness as well as that evenness. So proportionally out of the total, you know, are they kind of equally represented, or do we have one that's dominant and the rest are kind of rare? Okay, so those are your community comparisons. Moving on to the abiotics, I think this part is fun. So this is where we try and say, well, this is why, right? So you guys were out there, you had your soil core, or Taylor did, and she took a pH meter and added water to some of the soil and came up with these pH values. Okay, so the MESIC and the xeric, and you've got your pH, remember, basic to neutral scale. Okay, so let's graph these. Let's see if visually we see a difference. So rather than do a bar graph, we're going to actually do a different kind of graph, which is a box and whisker plot, right? So I'm going to highlight these. I'm going to go over here to this graph here. So normally we go to the bar. We're going to go over here to the statistics chart. And we're going to choose this box and whisker plot. That's pretty exciting. All right, so firstly, this is really not informative at all, right? We need to go over to our chart element and we need to add in an axis title. Let's do the vertical first because that seems to be most important at the moment, which is, this is soil. Oops, I need to click on it to make it active here. Soil, oops, pH. And I also want to add in my horizontal and say that it is site. Normally you can type it right in here, up in the formula window. I just don't have it active, I think, right now. Okay, now we don't know what blue and what orange represent at this point. So we also want to add a legend. And we can put it, you know, on the right if we want to, or underneath. So I just went into the add chart elements to legend, okay? All right, now, what this is showing is the median of our mesic's soil pH, the median value of the mesic, and the xeric. If there was overlap, they would be statistically, there would be like a statistical thing that we need to evaluate. So let's just put this one aside and let's move over and do our moisture graph, okay? So we've got our moisture graph right here. Insert, go to that statistics chart. Okay, and again, we want to know what this is. So we'll go over and add the chart element. The vertical is soil. I don't know why it's not doing. Normally I can just type right in soil moisture. Okay, we want to add the x-axis title, which would be site. Oh my goodness. Okay, and we want to add our legend so we know what those colors mean, right? And now you'll notice, the trends are different, right? So here, soil pH in the mesic is higher than in the xeric. So you guys could Google the range of soil pH and kind of see, is one more acidic than the other? Which one is more acidic, right? Or which one's more basic? For the soil moisture, these median ranges for both of the sites kind of overlap, right? They're very similar. So maybe there's not a difference. We haven't done any stats yet to know, but that's kind of what the trends, maybe the trends are showing that, right? So there's our soil moisture. Now we're over here with our light levels, right? And we can go over here and we can insert our box and whisker. So similar to what we just saw, right? Let's add in to make it informative. Horizontal is our site. Oops, click on it to get that active again. If you lose it, it's in the design area. And vertical is going to be our light level. Oops. Excel's like freaking out on me right now. All right, I have to give it a moment to catch up or something. It seems to be stuck. There we go. Canopy cover, right? Because we looked at, we were looking at canopy cover, and these appear to not be very different, right? They're very similar to one another. I'm closing this again because it's acting funky. We need to have a legend, right? So add the chart element so we know which one is which. All right, so we've got our graphs. These are the box and whisker plots that would be useful as you guys build your PowerPoint to kind of explain what some of those trends are. You know, we see these two different tree communities. Once your graphs are made, is there one of these abiotic factors that could help explain why those sites have different composition, right? And so, you know, some of them look similar, some of them look a little more different, but is that a statistical difference, right? It's hard to know that until we do a statistical test. So what I'm going to do is I'm sorry, my Excel is just like my kids say with Fortnite, it's lagging. Letting me move these. There we go. So I have a little spot over here where we can do our t-tests, okay? So we're gonna statistically test whether or not the trends that we're seeing in these graphs really are showing that those abiotic factors are different at the two different sites, okay? So if you remember, I think we did this in our muskrats. We did a t-test, right? So equals t.test. And now you need to show us the arrays. What are we comparing? First array is the mesic, comma, second array is the xeric. Whoops, I'm in the canopy area, so I need to be down here. Sorry, I was in my mind, I was testing pH because of the order, but we're actually in the row for canopy here. So we need to go down here. Mesic is my first array, xeric is my second array. It is a two-tailed t-test. So we're going to have two twos to end that out. Okay, so it's a two sample equal variance and two tails. And we'll hit enter. Okay, so we have a p-value that just got reported back to us of 0.316. Remember, with the p-values, we're comparing to 0.05, right? Anything less than the 0.05, we have statistical difference in the means that we're comparing at those two different sites. So in this case, how do you interpret that, you guys, with canopy? Anybody? Our p-value is greater than 0.05?
Yeah, much greater.
Yeah, so any difference in those sites? And again, we can go look at canopy cover graph. Is there any difference? Here's the canopy cover graph. Do they look similar in the two sites? Right, those bars, not much of a difference.
Sure, do you mean just like where they are in?
Yeah, the values, right? So the values here, you know, there's only a slight difference in those values, right? And so, you know, when we do a statistical test here, a t-test, to find out whether or not we have truly a statistical difference, it's showing up as greater than 0.05, no statistical difference in that canopy, right? We can go over here to the moisture and do equals t.test and find our moisture data. Remember, the t-test needs array 1 and needs array 2, and it's a two-tailed, and it's a two sample equal variance. And moisture, ta-da! How does it compare to the 0.05? Way over, right? So that also, no statistical difference. We can do our final, which was pH, right? So again, go back and look at your graph, and now you have a statistic which is less than 0.05, right? Our p-value less than 0.05. So you can speak to, perhaps, of those abiotic factors, maybe one of them having some statistical difference between those two sites. So again, those groups that get assigned, you know, pH versus moisture versus light levels, you guys would be drawing from the graphs that you have here, your t-test that you're doing, and the general findings about the forest structure to help in explaining if your factor, your variable, the canopy cover, the moisture, the pH, the soil series, or living things, the biotic factors, played a role. We're not going to do a t-test or anything on the mesic and the xeric sites soil series, but across the board, you can see, right, your mesic was all coltan and Adams. And in most cases here, pits and gravel. So there actually is a difference there. So if there was a group assigned soil series, or you wanted to bring that in to help explain things in your story, in your presentation, you know, you could do that. Okay. Let's just quick look at biotics here. This is our mesic site. Did we see woodpecker? This is our xeric site. Did we see woodpecker? Beech bark disease, and so on. So again, if you wanted to draw in some of these biotic factors that you saw, you can do that as well. Okay. I think that's all I needed to show you guys. You are assigned a group. I'm going to send out an email. In that email will have, you know, everybody's email addresses, and I'll give you an assigned biotic or abiotic factor that you guys will focus your presentation on, right? That presentation for the assignment that you guys have. And again, just reminding you of that assignment. When you present your results, you know, everybody's going to present density, dominance, frequency, importance graphs. But when you go to bring in those other things like soil or light levels or biotics, your group may only be presenting that one that you were assigned, okay? And using that as your kind of your filter, that is how I'm going to try and explain the findings that we got in density, dominance, species richness, and whatnot. It'll be based on whatever one of those biotic or abiotic factors that you guys were assigned. Otherwise, you'd all be presenting the same story. And I just would rather you go deeper group by group so that we all can learn from each other. So that is my hope. So yeah, there were a lot of new formulas that you guys got this week. Again, there'll be a video that is posted walking you through the process so that you can step your way through doing the calculations on the Xeric site on your own. But I will also be posting this Zoom for our international students up in our Zoom area, right? There's an archived Zoom thing. So, you know, feel free to refer back to this process as well as the completed data analysis video. Okay. Do you guys have any questions? Again, not due this coming week. Anybody? I have office hours tomorrow that are posted, Zoom office hours. They're posted up at the top of our page. If anybody needs to meet with me, you can shoot me a quick message so I know that you're going to be popping on. And if there were quite a few of you that needed me, then we'd have the ability to kind of portion off the day and try and fit you in one-on-one that way. So anyways, if you guys don't have any other questions, that's what we're working towards. You're going to hop off, you know, maybe give a stab later on once this resolves and gets posted. This video gets resolved and gets posted onto the Moodle site. You'll have something that you can pause along the way as you work through your Xeric analysis. Okay?
Sounds good.
All right. You're welcome, you guys. Have a good rest of the week, and if you need me, definitely shoot me a message, okay? I'll be on Zoom tomorrow.
Can I actually talk to you?
Yeah, can you shoot me a message and we'll do a separate one-on-one Zoom?
Absolutely.
Okay, thanks.
Thank you.
Danielle, do you have office hours on Friday?
Shoot me a one-on-one. We can schedule one.
All right, sounds
All
good.
right. Okay.
Thank you.
Bye, guys.